Hello, Jeff Edwards here. Today we want to come back with you and speak along the lines of what we term electronic infrastructure reliability. Electronic infrastructure is the foundation, the basis upon which virtually all businesses operate today, whether a small office complex with the building security system, the alarm, the access controls, the servers, or it could be as big as a Coca-Cola bottling facility with the packaging, the bottle washing, the filling, the capping machines, or a variety of other types of businesses today. Fact being is, everything we utilize today in business relies upon electronics, upon microprocessors. There are a number of things that make up electronic infrastructure reliability, and those are facility grounding, lightning protection, surge protection, UPSs, generators, harmonics, power factor. All of these facets make up electronic infrastructure. And our focus really begins to rely on and look at the foundation. And the foundation of electronic infrastructure that we point out is grounding and surge protection. If we're going to build a building, we need a great foundation, and those are the foundations. Now, in traveling outside the USA, many companies tell us, I don't know really what you have to offer us because your electrical grid is secure, it's stable, it's there. You don't go for hours with losing power, and our response to that is, yes, that is true. I said, but we're here to discuss more than just the supply of electricity. We really need to dive into the internal workings of the facility itself and its electronic equipment. And so quite oftentimes we point out power quality studies, one particular from Europe, it was about 2008 or so, and it surveyed 8 to 10 different countries across the European Union and discovered that of all the power quality anomalies, they were spending 150 billion euro a year to address these particular events and occurrences. And of that 150 billion, full 1/3 or 50 billion euro was spent to address the cost and impacts of transients and spikes and surges. What that money was spent towards was loss of programming in equipment, equipment lockups, microprocessor damage, motor damage, or other damage of processing equipment. NEMA, just a little over 2 years ago, conducted a similar power quality study. And what they found was that over 70% of businesses experienced some form of software confusion or system lockups or processor lockups. And a full 90% companies suffered more than 1 hour of downtime due to power quality issues. So you see, it's not just the supply of electricity, it's the issue that's at stake here. It's the reliance now upon an electronic infrastructure that comprises virtually everything within the facility itself. So we want to look at a paradigm shift from not only looking at the main service, but looking further down into the facility itself. And it's no longer just the main panel. It's no longer just the electrical equipment. And as discussed, it requires a different technology to really receive benefits from implementing new processes, new 21st century processes. And we do that with what we call cascading. And by cascading, we're looking at not just the main power, but we're looking at the supply voltage and the control voltage. At minimum, 2 levels of protection for control equipment, microprocessor-based equipment. And we were approached about 7, 8, 9 years ago by a major oil company, and they brought to us the situation that in one particular producing field, they were losing upwards over $1 million a year and 30,000 barrels of oil of deferred production or lost production. And when they showed us their prints and diagrams, they were utilizing the industry expected means by protecting the main disconnect of a variable frequency drive pumping operation, primarily electrosubmergible pumps. And as we assessed that and examined what they were utilizing, it made zero sense to look at implementing our technology versus theirs just for one unit, or one panel. So we recommended this cascaded approach within the structure of a variable frequency drive cabinet. In this particular instance, because it was a 12 pulse VFD, we recommended 5 separate units for this one application. And immediately it was like shock and awe. Do you realize how much this is going to cost? Well, yes, we did. So we invited them to come to our facility, our factory, fabrication, and our engineering offices and our laboratory. We supplied equipment, and they brought equipment that they were utilizing, and we did a side-by-side comparison. And at the end of the day, we validated the fact that our cascaded approach with our frequency attenuating technology and our 10 modes of protection within the devices was able to take a 20,000 volt, 10,000 amp surge down to about 25 volts. We went back to the field, began to implement a small test scenario case with maybe 30 to 40 wells. Over the course of the following 9 months, we saved them almost 26,000 barrels of lost production and around $900,000 worth of direct expenses. Once seeing those results, they began to implement throughout the entire one producing field. And over the course of the following 4 to 5 years, we enabled them to produce another 107,000 barrels of oil per year. Now, that may not be a whole lot of money today, depending on the price per barrel, but then we're reaching up to $100 per barrel. So the thought and the need for cascading becomes accentuated within a manufacturing facility, for example, with multiple layers of control cabinets and drive cabinets and access control and 4 to 20 milliamp type protection. There's a great need for cascading. But utilizing the correct technology that we offer with Tamer internationally and SSI here in the United States, you can obtain verifiable, quantifiable results with an ROI sometimes in as little as 1 month. So implementing the right product in the right locations enables you to get a return on investment that keeps giving year after year after year. Now, for additional information, please contact us either at our website, www.ecsintl.com, or via email at info@ecsintl.com.